Hello, everyone, and welcome to the GeekNarrator podcast. I am your host, Keval Yapte. Let's imagine you have a database and you are serving production workloads. There's a lot of data, and you're running queries, you're running reports, you're doing a lot of summing, you're doing aggregation, you're counting on certain things, and you're also calculating averages and those sort of queries, right? But one day you imagine you have a problem where your query latency is shooting because of a lot of data or something like that. And also your costs are increasing. So what do? You need some kind of optimizations, right? And for optimizations, there's a limit and there's also effort required for you. And let's say you don't have time. So what can you do? So today we are going to talk about a product that will help you achieve the reduction in your latency and also your cost with your existing database with minimal effort. And that product is Epsio. So, to talk about Epsio, how it works, what the product has to offer, and how it can help you, we have the CEO and co founder of Epsio.io, Gilad Kleinman. So, welcome, Gilad. I'm really happy to have you today and also happy to dive into the depths of how Epsio works and how it can help me as a database owner who wants to improve the performance and reduce the cost. So, thanks a lot for joining. Let's start with a little bit of introduction for our viewers.
Sure. So really happy to be part of this podcast and great to see you all. A little bit about me as a background. I've been a software developer for most of my senior life. Worked at a couple of startups, a couple of bigger companies. I had also a very short period as a product manager. I know a little bit how the more customer facing side of businesses work. But still in my heart, love everything related to technology, specifically backend development is where I've been most of my career. And that's it. Excited to be here and talk about what we've been building for the past few years.
Amazing, amazing. Yeah. Although I shared a little bit of the problem statement, like you have a database and it's slow and you're doing all those aggregation style queries. But let's throw some light on the core problem that we are trying to solve or Epsio is trying to solve.
So I think that's a good point. And I think like one of the reasons that brought me to work on this was basically experiences I had as a backend developer. And I think in a very fundamental way, like always when you're building a new feature or starting a new product, at the beginning, everything is very simple and very fast. You have very little amounts of data. Your queries are usually very simple. But as the product matures and as the company as a whole matures, I think two very interesting things happen. First, data gets bigger. Haven't heard of a production deployment where the data decreases as time passes. It only goes up.
Yeah.
And additionally, the product obviously gets much more complex. Suddenly you have more tables you need to join. Product management comes and asks you to add another filter in the dashboard, do another correlation, show the mean and not just the average, and yada, yada, yada. And a very fundamental way, this thing that happens as time passes by creates this gap between the data you store in your database and the data that you show and the data that you use in your application. For example, if I'm building an HR SaaS product, the data I'm storing would probably be, for example, salaries of employees in the company. But the data I want to show is not that base table of rows of salaries, but it would be interesting analytics or interesting things on top of it. For example, the sum of salaries in the company, the average salary compared to a benchmark of average salary per department in the world.
Yeah.
And as there's more data and these queries become more complex, your database needs to do more work to bring it from here's a list of salaries to here's what I want to show in the dashboard. And as there's more work, obviously that means queries are much slower. That means customers are less satisfied. That means your database, it's doing a lot of work, which probably means you're going to need to make it bigger. Basically introduces a whole lot of problems once you're getting to that point.
Absolutely. I totally agree. And I've seen this problem, right? Everyone starts simple. There's a simple use case. There's a simple database, probably a few tables. But then as the product evolves, the product manager comes to you, you have to add more features. Of course, you're onboarding more and more customers, so you have more data. And as you said, data never, decreases. It always increases unless you have a bug or something. And I hope no one has that kind of bug, but the data is always increasing. The complexity is always increasing. The more features you want to support, you want to write some complex joins, some complex queries, and do aggregations on a large data set, and which is, as you said, more work for the database. And then I, as a developer, when the product manager comes to me, or there's a customer that is complaining that, oh, my report is too slow, or the experience is not great, I certainly think about optimizations, right? Like, how can I optimize the query? But I don't see, let's say, scope because it's a basic query or I'm doing all the things right. So I end up implementing more and more layers on top of database. Like I cache the value or show some stale values. And the point I'm trying to make is there's a lot of effort and there's a lot of tricks that go into implementing those things, and it can get complicated and it's really difficult to support. And I, as a developer, what I've learned so far is whatever you get while writing as less code as possible, that's best because you have to maintain less and there's a low possibility of bugs. So yeah, I totally relate with that problem. And instead of increasing the complexity, it's always best to either keep it same or reduce it eventually.
I think also that specifically, like a lot of the things I used to do as a developer is optimize things. And even if the optimization is very simple, at the end of the day, it's making something X times faster, right? If I have a query and I add the right indexes, it will make it 100 times faster, but it never solves the problem, right? Because if you're making a query 100 times faster, but then your data gets 100 times bigger, you're at the same point where you started. So for me, it was really interesting to look on places that try to solve the problem, not just postpone it, where you make the performance better, but you know that in a year, you're going to need to work on it again, even if the fix right now is relatively simple.
It's just pushing the problem in the future, but not really solving the problem. And again, there is cost involved because instead of improving those performance things, I can work on adding more features and not worry about the performance, right? So it's a balance you need. Okay, I think the problem statement is clear that I want to put minimal efforts but get those performance optimizations. So let's try to introduce Epsio, right? Like for this problem statement, how is Epsio going to solve or fix the problem? And what Epsio as a product has to offer?
Yeah. So if we go back to like the high level description of basically the gap between the data you store as a developer and the data you want to show in your application, when we started working on Epsio, we tried to think of how things work today and what fundamental change we can make to fix and bridge that gap. And the very, very first thing that we came across and thought when we started to think about it is the fact that today databases, every database that there is, every time you query something, it does the entire calculation from scratch. And one of the weird things about that is as a developer, usually you run the same queries again and again. For example, if you have a dashboard showing, go back to the HR company example, you have the front page is a page that shows the sum of salaries. Yeah. That's a query that's going to run a lot of times again and again. Yet every time you ask the database, hey, what's the sum of salaries? It's going to do the entire calculation from scratch, as if it's the first time anybody asked it that. So for us, the first step of bridging that gap is building on mechanisms that doesn't require that computation again and again every time you ask it, and basically allows developers to define specific queries that they know they'll want results for. And instead of doing that again and again, just at the first time, make the initial calculation, save the result, and then update the result as changes occur. For example, if I have a select count statement, Epsio will initially go through the entire data set, save the result. And from that point onward, if there's an insert, it will just do +1 to the old result. There's a deletion, it'll do a minus, et cetera, et cetera, et cetera. And basically that gives the upside of quick results, right? Because when you ask Epsio, hey, what's the sum of salaries in the company? The result is already calculated. So on the one hand, it's fast because it's just a simple read from the disk. Yeah. But on the other hand, on like caches or materialized views or other solutions that you have there, it's always up to date because it basically changes as your data changes. So that's like a very high level, I think, overview of the basic theory behind Epsio. And this is basically the base and the heart of what we offer.
Interesting. Yeah. So basically, instead of recomputing, Epsio will save you that cost of recomputation. And when I say cost, it's also latency, right? So it looks good, but how does it work? Like, where does Epsio fit into? So let's imagine I have a like simple looking architecture. I have a front end. I have a backend application that talks to my database. So it's like a simple 3-tier application, right? Where does Epsio sit? So how would my architecture change when I want to integrate Epsio?
So that's a great question. I think one of the funny things about this is that Epsio originally was a new database
Hmm.
that we built. And pretty early on, we talked with a handful of backend developers and companies. And we heard the same thing again and again. There was a quote specifically that I really liked that said that migrating a database is like changing an engine's car while it's driving,
Hmm.
which means even if a lot of developers would have another database that will bring them much faster results, save a lot of infrastructure costs, the
Hmm.
cost of just migrating a database and forcing the backend to query another database, moving all the data while things are running is something really hard.
Hmm.
So basically, we understood that as important it is to provide fast results and reduce infrastructure costs, it's also really important to be able to integrate this easily without migrating any databases.
Hmm.
And taking into that in mind, basically the way you deploy Epsio is you plug it into your existing database. For example, you have, as you said, front end talking with the back end, and then you would have, for example, a Postgres deployment. Epsio will come behind that Postgres deployment.
Hmm.
And then two things will happen. The first thing is Epsio will subscribe to Postgres to receive all the changes that occur. And Postgres specifically, it's using logical replication, basically sends any update, insert, delete that happens to any relevant tables in the database.
Hmm.
So that's step one, that basically notifies Epsio every time it needs to update a query result.
Okay.
And the second thing is for you to query Epsio, every specific query that you define that you want to query, Epsio creates a virtual result table in your
Hmm.
original database that whenever you query it, it queries Epsio.
Okay.
So basically combining these two things, it basically allows you to still query the same database that you're using. The backend still queries the Postgres. And for every specific query that you want to have fast results for, you just define that query in Epsio. Epsio creates a results table in your original database, and you can just query that result table in the
Hmm.
same Postgres
Okay.
without needing to query any other engine.
Okay. Okay. Interesting. I think I have a like a high level understanding of where it is going to fit, but I have a couple of questions just to validate my understanding and really understand how it works. First, you said that it basically I don't need to migrate my database to a new database, and thanks for doing that because I know it's a pain. I've done that, and it's always been ending up with some issues. There's stale data, or there's just downtime, or some weird issues always happening. And it's a challenge. As a developer, it's definitely a challenge. There's a lot of learning, but at the same time, for a product, for a company, it's not great. So thanks for not creating a new database, but solving the problem right there. You said Epsio subscribes to the events that are happening with this within, let's say, a Postgres database. So is it like how that works? Is it like a CDC that it just listens to that and tries to update something?
Exactly. Yeah. It's basically CDC on the Postgres. We're using
Hmm.
like built-in features in Postgres
Okay,
that basically allows you to send CDC on tables.
interesting.
Exactly.
So when you said Epsio creates a new table for, let's say, the query result or something, is it creating the table in Postgres, or there's like a specific store that Epsio uses?
So that's a good question. And basically, going back to the architecture, so if we said there's a backend, there's an instance running the Postgres, Epsio will run on a
Hmm.
separate instance by itself,
Hmm.
store the results in a specific format, specifically for that's built in for Epsio. And the table it creates is a virtual table in the original Postgres that
Okay.
basically, whenever somebody queries that table, Postgres is configured to query Epsio.
Okay.
We're using something not a lot of people are familiar with it, but you're welcome search is called foreign data wrappers in Postgres. It's basically a feature that allows you in Postgres to define a virtual table. Whenever you query it, Postgres queries a separate engine. And this kind of, again, allows us to hide behind the Postgres and create these virtual tables without the backend even knowing there's another engine there.
Okay, interesting. Okay, Epsio is running on a separate instance, right? And is receiving those CDC updates. It is using the virtual table that Postgres supports using foreign data wrappers. And it creates a table in Postgres. But whenever you make a call, instead of recalculating values, it configures Postgres to use that virtual table instead so that your queries are faster, right? Okay. So that makes sense.
Mm-hmm.
And you mentioned about, so for our viewers who are not really familiar with how these virtual tables work and how would the permissions work when I'm creating, like, let's say, new table in Postgres. So what kind of permissions do I have to give to be able to do that? And how is that set up?
So basically, one of the nice things about these foreign tables is that they act very similar to normal tables in Postgres, which basically means that just like any other table, when you create it, you need an admin right, exactly like you need one to create a table in the schema. And once you create it, you can just grant other Postgres users permissions to, for example, select. You can have permissions to edit these tables, etc. But one of the nice things that Postgres does is it basically allows you to work with it very similar to just a normal SQL table, whether it's permissions, whether it's querying, etc., etc.
Interesting. Yeah, that sounds good. And the permissions is fine. You have to grant the permissions to the specific users, and that's how it works. And Postgres supports very nicely. The next thing I wanted to ask was around, you said as a user who wants to integrate Epsio, I definitely know what kind of queries I'm running on my database, right? So I know what kind of queries are slow and what I want to do. So how this configuration works. So I have to configure my queries beforehand so that Epsio knows what kind of structure of the new virtual table is going to look like and what is exactly happening, what is the recomputation that is going to be performed, and then how it is going to store the result. So how does Epsio parses that query into something like a virtual table?
Great question. And first of all, regarding what you said about developers knowing the queries, that's actually a good point because we're thinking a lot about whether to try to choose ourselves which queries to optimize. And pretty early, we understood that the developers know themselves the best what are the slow queries. And more important than that, what are the business critical queries, right? Because you might have a slow query, but it's like at a page that nobody enters and that's not important for you. So I think that's a really important point you make, that at the end of the day, we're trying to build an interface for developers to choose themselves. And we're not trying to decide or claim we know better than the people building the applications, which queries are most correct. So that's just a side note about that, because I very much agree with what you said. And regarding what you mentioned about the interface, so basically, again, we try to make it as simple as possible. And so basically the interface that we give developers is, if you have a slow query, let's go back to maybe the select count example. All you have to do is call a procedure in your original Postgres database called epsio.createView. And then you need to pass it a name of the new view, and then just the SQL query that was slow. And basically what will happen in the background is, first of all, Epsio will basically understand from the SQL query how to build that engine that knows how to update the results according to the query. But that's that we do. You don't have to understand and think of how to build that engine. We know how to parse the SQL query. And the second thing, when you run that, it automatically creates this whole mechanism of adds the relevant tables to the CDC and creates the foreign table to point to our result. So all those things happen in the background. All you have to do is just give us the query, give the name of the virtual table you want to query from, and that's basically all.
Okay, interesting. I like this pattern because when someone is trying to optimize something, there's definitely a problem. And to optimize that problem, you should understand the problem, which is basically you should understand the query that you're trying to make faster. So I agree that all developers would know the queries that are performing slow and then configure it accordingly in Epsio. And that makes a lot of sense. For our viewers, you used a couple of terms. For our viewers who might not be aware of those terms, you said view, right? What is a view in when we talk about Epsio? And maybe this is the right opportunity for us to cover some of the concepts that Epsio needs you to know, like what is happening behind the scenes. So let's start with views maybe, and then we can maybe cover like materialized views or something like that.
Sure, yeah, I'd love to. So view is basically like a concept which FCO, I wish we had invented the concept of views, but it's been in the database world for a very long time.
Mhm.
And it's basically something that allows you to simplify a lot of the work in front of databases developers do. Basically, it allows you to create a virtual table, very similar to virtual tables we have, that whenever you query that virtual table, query runs underneath. For example, if you have a query that a lot of people do, for example, selecting the top employees in the company, and that's something a lot of people run again and again. And you want to have some sort of simplification above it to help people run that query more easily.
Mm.
What you can is you configure a SQL view. Almost all SQL databases support that, which basically means that whenever somebody queries top employees table, what will happen is this query will run, actually brings the top employees. And basically that allows like people to query that virtual table without understanding what's exactly happening in the inside.
Mm.
Very similar to functions and coding or things like that, where you want to separate between the API you have and between the implementation internally. It also allows you, for example, to change the view definition without actually changing all the places that reference it.
Okay. Yeah, that makes sense. And thanks for expanding on that because it's really important. So this is all interesting, right? And so what I have so far is I have Epsio that is running on a separate instance. I have my Postgres database. As a developer, I know my queries, which are slow. I configure those queries, I create those views, and then Epsio knows how to create the virtual tables, given I have granted the permissions. And the virtual tables are basically storing the data, the result of your query, and avoiding the recomputation. And that helps me reduce the computation cost. Where is the cost optimization exactly coming from? Are there more factors? Is it just recomputation that is saved, or what else is happening?
It's basically recomputation that is saved. But one
Hmm.
of the interesting things that we saw in production databases is that there could be a lot of recomputation happening. There are some companies we work with that almost 90% of their production database compute power went to queries that, for example, one company had the same query running 20 times a second. And 70% of their compute was just going for that query running again and again and again, 20 times a second. And basically by making these computations unrelevant, because we just looked on the changes and not did the same operation again and again, they could lower their database size significantly. Yeah, because compute power
Yeah,
costs a lot, if
absolutely.
that makes sense.
Absolutely. And I think that this problem amplifies when, so for any business, there are like, okay, there's like average days where the business is not like doing okay. But then there are peak days when something like a Black Friday, where there's a ton of orders coming up and a lot of customers are looking at their data and you are running a lot of reports. And people usually do a lot of load testing to identify what are the peak traffic, and then they scale up their database and still face issues because even the largest machine on Amazon that you have, even if you have that, if you're doing a lot of recomputation, it's always expensive, it's always slow. And I've seen this problem multiple times. And if I get this optimization without writing any code, I think I'm more than happy to do that. Given on that point that it uses CDC and it gets the event, what is happening, and then it updates. Whenever I talk about CDC, there's, as you said, it uses replication. And then whenever replication is happening, there's the problem of replication lag, right? So with traditional databases, what I do is I get this beautiful property of read after write. So I insert data and I read right after it and I get like the updated count. Is there some kind of a lag that is happening? As a developer, should I know that, okay, this much lag I should be okay with? or somehow you try to solve that problem as well?
That's another really good point because exactly since we're reading CDC, we're not always exactly correct.
Hmm.
I call it eventually consistent, meaning
Mhm.
eventually we're going to have the right result, but it might take
Mm.
a few milliseconds or a few tens of milliseconds depending on the load. First of all, on the default, definitely something you should be aware of. And the default configuration of Epsio basically occurs with an eventually consistent promise where you might do an insert. And if you right after it select from Epsio virtual table, you might not see the insert that you had before.
Mm.
I will say now, it's also a bit talking towards the future. One of
Mhm.
the things that came up during a lot of conversations we had, and we actually started working on this recently, is a new feature that will allow to block the read until we received all the relevant writes. For example, you can imagine if you do an insert and read right after that on Epsio, you can configure specific views that you want to always have up-to-date results. And what Epsio will do is just wait until we receive the relevant CDC for that, for
Mm.
all the inserts before the point of time where you did the select, and only then fetch you the result. That's very good on the one hand because it means that you're not eventually consistent and all the results you're getting are always correct right now.
Yeah.
On the other hand, it means the results are going to take a little bit longer to reply. Because if you
Mm.
have, for example, a replication lag of 50 milliseconds, that means that when you select on us, there's going to be additional 50 milliseconds of wait until you get the result. And then we made sure that we got all the relevant writes. So that's a little bit of the future that's still not generally available. But that's a good question. And that's something we get a lot. And it's important when you're using Epsio that out of the box today, there is a lag between the views and the actual original Postgres table.
Yeah. Yeah. That makes sense. And it's basically a trade-off, like anything else in software engineering, right? Like you get something, but you have to lose something, right? And not always. Like you lose something, maybe, right? It's not like always you're going to lose consistency, right? Maybe most of the time it's just consistent, depending on your workloads, and other times it's just eventually consistent. I think what matters most in my experience is that it should eventually be consistent and not be ever inconsistent for a longer period of time. So you definitely have some sort of SLOs for your service. And it all depends on the type of workloads you have. With that, I wanted to ask you, what is a good type of workload for something like Epsio? I imagine, let's say there is a read heavy workload and there's write heavy workload where like data is coming in at high pace. So it definitely will amplify the process of pushing those CDC events and updating the results. So what kind of workload Epsio is most suitable for?
So I think generally speaking, in terms of read and write, I think until today, we haven't had a lot of issues with heavy write workloads. Like
Hmm.
we're pulling the changes relatively fast and our lag is not high until today. So that hasn't been a problem with the customers we've um, been working with. I will say though, I think the thing that matters the most, whether we're relevant or not, is the queries you have.
Hmm.
That means that I talk with a lot of companies that most of their queries they have a very read heavy application, but most of it is a lot of simple selects with a lot of filtering and a lot of varying queries that don't repeat themselves. I think that the thing that the most decides if we're going to be able to help or not is if your queries are complex and heavy. They don't have to
Hmm.
be crazily heavy, but they have to be more complex than a select with the where clause.
Yeah.
And additionally, how repeatable are the queries? If, for example, every time you run a query, it's very complex, but it's very ad hoc-y, it means every time it's a query somebody builds, but never repeats itself,
Hmm.
sadly, we're probably not going to be able to help there a lot. Based on my experience, I think this is the thing that matters the most, looking on the application layer, less and less on the data insert read ratio, if that makes sense.
Yeah, I think that's a good point. And if your query is not going to be repeated a lot of times, then you will just compute the results and never use it. So it doesn't make a lot of sense. Even for ad hoc queries, as we said, like coming back to the initial point, developers know what kind of queries are slow. And these are the queries that are, let's say, reported or it's clearly visible. They pop up and figure out, okay, there is some issue. And these are the queries which are really heavy, but really important, right? And those are the type of queries really suitable for Epsio and not like ad hoc queries that might happen once a while and never after that. And it's also, as a developer, I cannot really configure those queries because these are all ad hoc, right? Even if I configure, I don't have a way to say it is better or not because it is never used, for example. Yeah. Again, as a developer, I should know what I want to optimize and what are the trade offs after I do the optimization. And it all makes sense. Let's talk a little bit about, since you mentioned like complex queries, right? So there's a lot of joins happening, there's aggregation, like group by, order by, a lot of things happening, right? How does the creation of virtual table works when I'm combining, let's say, two tables or joining on two tables? I guess it's ultimately it's just one virtual table, but I just wanted to clarify with you.
Yeah, exactly. That's a good point. At the end of the day, we're separating the query and the result.
Yeah.
Because, for example, if you run a complex query that does join on 10 tables, do a lot of ordering, group by, a lot of complex things on top of it. At the end of the day, that query is going to give you a simple table, single table as a result. And that's also exactly what we do. Basically, when you create that view, we'll now start tracking all these 10 tables. We'll understand the ordering, internally ordering. We'll know how to update every relevant result on every one of those base table that changes. But the result would just be one single table, exactly like you'll get if you query it. And yeah, again, you can use joins. One of the things we work hard a lot at supporting a wide variety of SQL. So you could use joins, you could use group bys, you could use subqueries, or basically use most of the features that SQL offers you. But at the end of the day, the result is just going to be a normal table, no matter what you define in the query.
Okay. And as a developer, I don't have to know about it, right? Because it's all happening like behind the scenes. I just know that Epsio is going to use it. I have to grant the permissions and it's all good. Great. For all the curious developers out there, right? I understand there's a lot of value coming with integrating Epsio because it saves cost, it improves your performance. I don't have to do a lot of changes. But for developers who are more curious, how does Epsio's approach compares with something like updating a cache?
So I think, so again, I'm trying to understand how does it compare to maintaining a cache?
Yeah.
Right.
Yeah.
So I think primarily the difference and the big problem we had with caches is that caches are great until data changes. And using CDC and different things, you can very easily get notified when a change occurs. But it goes back to once a change occurs, how are you going to make the update? And for example, a select sum, that's very easy, right? You can have CDC. You can on each new event do plus or minus. That's something that's relatively easy. And I think, well, most developers would be able to build themselves. I think the interesting thing is the more complex the query, the harder it's going to be to create that and build that yourself.
Yeah.
And also, funnily, usually the most complex queries are the one are the slowest. So usually like queries we see are queries with 5 joins, ordering, distinct, where you need to find distinct values from each combination of tables, then order it, then do another aggregation, and then save the result. And suddenly it's very hard to write that mechanism using CDC, Kafka, and like a mechanism that tries to pre-calculate it. And even if you are able to write that, which sometimes we see companies that do like really impressive things that to maintain results of these aggregations using CDC, a lot of the time that it's very static and hard to change. For example, if you spend now a month and you wrote like a mechanism using CDC to maintain a result of a join of 5 tables and a distinct on top of it, that works great. Now you want to add another table. Now you rewrite a lot of code and like manually understand how do you change that to the new query. And I think one of the things that were very appealing to us is try to separate it from token SQL, and it doesn't matter the implementation. And that way you can also move very fast. If you want to add another join, it's just changing the query and adding another join. And you don't have to rethink and reevaluate basically all the logic that you wrote until now and understand if it still works on every change, if that makes sense.
Absolutely. Yeah. Over the years, what I've learned is your when you're trying to optimize something of that sort, it's definitely critical, it's definitely urgent. And you don't want to just create a whole new system like CDC and then updating a cache and then creating 10 new problems. I think it's best to use something like a product that specializes in that area. And then, as you clearly mentioned, that with time, you add more complexity, you add more new features, and then suddenly there's again this bottleneck. Oh, again, the query is slow because you did something wrong, there's bugs there, and you have to maintain, but then you have to deprioritize the amazing feature that you were trying to add to the product. So there's all the problems that like you face in reality, and you want to avoid that. And the best thing to do is write less code, and I am a advocate of doing that. So great. So now I have a clear understanding of where Epsio is helping me, in what use cases it makes more sense, and how would the architecture look like. Basically, as a developer, I just have to configure the queries that I want to optimize and not really worry about the changes it will make in my architecture, because all the queries are going to look like same. It is going to the same Postgres node, and it is using the virtual table. Nothing is changing, which is great. But I still want some visibility into what is happening, right? Let's say as a lead in some team, I integrated Epsio and I want to understand what is happening behind the scenes and if it's all good or not. So what kind of metrics or monitoring does Epsio provide?
That's another good point. And one of the things we try to do very hard in the visibility and monitoring part is, again, try not to invent the wheel again. And we try to actually take a lot of inspiration from the way Postgres or other databases do these things. And basically, we copy the mechanism that, for example, Postgres, again, uses a lot, which is basically to have tables that show the status that you just query. For example, to see what status every view that you define, how lagging is it, if it's running, if it's not running, you basically just select a table that shows you the view, show you the list of views with their current status.
Okay.
It's just another SQL query that you can run on top of your database. And one of the good things about that is that you can basically add on top of that whatever monitoring or visibility mechanism you're using, whether you're using Datadog, you just configure Datadog to run that query periodically and just send the statistics back with the metrics and build alerts on it, whether it's Grafana or whatever you're using. It's just like a list of queries you can run on your original Postgres. That just show you the status. And today, again, the thing that usually is most interesting to companies to work with is the views to make sure that they're running, to make sure to see the lag, and just also generally you see that Epsio is still up and communicating with the Postgres. But at the end of the day, the most basic thing is just virtual statistic tables in the original Postgres that you can just query and see the status.
Interesting. Given that it's also at a high level, not if we go into the deep implementation, but at a high level, the architecture is so simple that it makes the monitoring itself simpler, right? So there's just one additional table that I don't really have to maintain, but I can just monitor if I want to see the lag and if it's getting updated and if the configuration is correct. Mainly when there is like really high traffic going on and I'm really worried about this query performance, right? That makes sense. And I know we have talked a lot about Postgres specifically in the episode, but I want to know what all databases are currently supported, or let's say if we talk about future, what all databases are you targeting to support?
Yes, I have mentioned mostly Postgres until now, and that's because until today, we're primarily focused on Postgres. I think also generally as a rule of thumb, we have like this saying that it's better to support 99% of one database rather than 80% of a handful of databases. So we're very focused on Postgres until today. Currently, we're at the stage where we feel we're at a very good stage, and we covered that 99% Postgres, and we're now starting to work on alpha versions. Like we currently have alpha versions of MySQL and SQL Server. They're not currently generally available, but that's one of the next steps, and one of the next big things we're working on is adding this functionality also and integrating in the same way we do with Postgres, but also with MySQL and SQL Server.
Interesting. Yeah. Just speaking a little bit more into the future, I think you mentioned like in the similar way, the integration would look more or less like similar, like we do with Postgres. Do we imagine it is going to be exactly similar, or there's slightly going to be changes? Maybe because some database don't support this concept of foreign data wrappers or virtual tables.
Yeah, no, so one of the fun things and one of the things that we made sure before we started working on this is that all the databases that we want to support have these capabilities.
Mhm.
And basically in MySQL, it's in different names.
Yeah.
In MySQL, it's called federated tables. An SQL server, I don't even remember the name. And the replication, the CDC is also something that all the databases that we plan to support have. And then obviously there's going to be a lot of small differences in terms of what are the commands you run, what are the edge cases, how do you exactly configure, but the basic architecture is remaining the same. You have CDC going out and then the virtual tables that are created on the original database that gets forwarded to us.
Interesting. Cool. For all the viewers who, after watching this episode or listening to, who might be interested in knowing more about Epsio and knowing how they can try Epsio in their workload and figure out if it can really help them, how can one reach out to you and how can one try out Epsio?
I think first of all, everybody's in. The thing I usually send is documentation. We have a more in-depth documentation where whoever wants can go read, see if he gets answers to all his questions and explore a little more. And after that, we have a free trial that we offer to whoever wants to try, give Epsio a dry run. You can just click on the website, ask for a free trial, and basically see if we held up to what we talk about.
Okay. That makes sense. And of course, free trials are the way to go. You try to test it out, you see how it works for you. Let's say I try out Epsio and it works for me. How would the pricing model look like?
So we're trying to be very, again, not try to invent the wheel. I'm trying to be very similar to the cost of RDS, for example, or any managed service, where basically we take a multiply on the compute you use and the storage you use. Both of them are like, you can select how many CPUs you want and what amount of storage exactly you want for the Epsio deployment. And we take pretty much the same amount that will cost you an RDS to maintain the same instance size. I will say again that usually in most deployments, the cost still goes down because we need usually a lot less CPUs to maintain a very big workload. You can use 8 CPUs to maintain a workload that an RDS would use 32 to 64 CPUs. So usually, even though there's like more cost going to Epsio, usually and not always, again, it depends on the specific workload, costs go down totally. Like on total, sorry.
Yeah. So I think we have covered like from the very basic to a little advanced things on how Epsio works, how it can help different developers, different companies out there. So thanks a lot, Gilad, for helping us understand what Epsio is doing and the technical concepts behind it, the architecture. And thanks for not inventing another database and integrating in the same database. For the viewers, for the developers who are interested in knowing more on how it works, I'll attach the Epsio documentation in the description, so do take a look at that. Of course, read more on foreign data wrappers, views and materialized views and virtual tables and how Postgres implements that. If you want to know more about CDC, I have also done an episode on that, so you're welcome to watch that episode as well. Otherwise, there's a lot of documentation on Postgres website as well. So feel free to watch that. For companies who are dealing with these problems where you have really high latency and you're dealing with a lot of cost, do take a look at Epsio, reach out to Gilad and try out their product. It really looks promising. And once again, thanks a lot, Gilad, for coming to the show and helping us understand all the technical details about Epsio.
Thank you for inviting me. It's been very fun.
Cool. Thank you.